Previously, we talked about producing engineering plan for a project development. There are various types of development: residential, industrial, or commercial development. To develop an area, first you will need a piece of land. The land may be owned by somebody else. As a developer, you will have to buy the land from the landowner. In terms of the profit sharings, it will be very much dependent on the negotiations and agreements between the developer and the landowners. The developer may purchase the land by paying the cash with an amount agreed with the landowner, or the developer and the landowner may enter into the joint venture mode with the agreement that after the development, a certain numbers of building units are to be handed to the landowner as a return to the landowner. Now it will be up to the landowner to keep those building units or to sell the building units at the market price. Whichever mode it is, it will be dependent on the preference between the two parties. The land title is another important issue. There are agricultural land, mixed development land, native land, and etc. Taking the agricultural land as an example, the land are designated for agricultural purposes. Now, should you want to have the development, such as for the industrial purposes, there should be a process of converting the land title from agricultural land into the mixed development land. Later, there should be subdivisions of the land into various units, so that every subdivided lot shall have the separated title, allowing the lot to be owned by different parties separately. Now the developer are selling those units. There are also other infrastructures, such as the roads and drain, car parks, and open space. This ultimately shall be handed over to the local authorities. This will become the common areas used by the public for various purposes. For building units, we will require structural plan. Engineer shall design the building structures in accordance to the architectural plans produced by the architect. The design calculations for the structural plan, as well as the detailings for the structural plan, are later to be submitted to the local authorities as a record. In case that there is a need to review those designs and drawings, those records are traceable from the local authorities. Similar goes to the engineering plan, providing the details of the road drains as well as the site layout. Together with the engineering plan, you will need to produce the road sections, indicating the design of the roads, as well as providing the ideas how the road sections looks like after the development. This is about the typical development process, assuming everything's are going smoothly. Next, let us talk about some design issues related to the soft ground conditions, as this may be a problem to areas with soft ground, organic soil, or peat. One of the greatest issues about the soft ground, it will be the settlement. Settlement is something that we do not like, as this can bring harm to the structures if not properly catered off, and excessive settlements may bring in other issues, both during the constructions and after the constructions. This picture shows the settlement problem of developed areas. What you see here, this is the building and this is the slab. Initially, the road levels is here. However, many years after the development, excessive settlements occur, leading to the lowered road levels against the initial plan. You can see the width hole here where the waters are to be discharged from the road into the drain. Now that because of the settlement, it is nearly impossible for the waters from the roads to be discharged into the drain. Ultimately, the drain here becomes redundant. Now, what leads to these conditions? The main reason here it will be the buildings is constructed over the deep foundations. Specifically, we are talking about the pile foundations. However, the roads are constructed directly onto the ground. Over the times, settlements occurs year by years. Significant settlements happens. By having the design strength to be redundant, that means the design does not meet the purpose over the years. Now, whatever surface runoff will have to go elsewhere. This may bring burdens to the other drain, or sometimes if the runoff cannot be effectively discharged, ponding of water or maybe flooding can occur. This is the building. The pavement is here, and this is amount of the settlements of the pavements. You can imagine the degree of settlement by looking at the typical dustbin here, which is about half a person's height. This is quite significant. This is another example. This is supposed to be a ground bin to be flush with the ground surface. Over the years, the soil settled, leaving there a significant gap underneath the ground bin. You can see here the pile foundations. This is another example. You have the pavement, culvert, and building. The building sit on the pile foundations. The culvert also sit on the pile foundations. Due to the settlements of the pavements, there is a drop after the culvert. These are the issues with post-development due to the soft soil. This is another case. The development here is on peat. Peat is an organic soil comprising high levels of organic matters as well as very high levels of water content. By looking at the color of the soil, you know it is peat. Very dark color. You can see the degree of settlements of the developed areas. One significant problem with the peat, it will be the low bearing capacity, especially when the water content is relatively high. It seems that they are now trying to do the site clearing in order to kickstart a project. Along the way, due to the poor bearing capacity, the entire excavators has now been submerged into the soil due to inability of the soil to generate sufficient reactions to support the weight of the excavators. These are issues with the soft soil or peat soil. Normally, when you encounter this kind of soil, there should be some treatments in order to improve or stabilize the soil so that the construction work can be carried out. This is another example of the problems due to the poor soil conditions. This unit has been abandoned due to significant settlement of the building. If you observe the columns here, you will see there are parts of the buildings being submerged under the water. This is the water level here, which gives you half of the building being submerged into the water. Ultimately, this will affect the functionality of the buildings. We do not like this to happen as an engineers. Now let us look at the requirements of the local authorities dealing with the project development in the soft soil conditions. This is one of the examples. You may refer to your local authorities if there is any guidelines or requirements related to the development. According to the guideline, the technical report throughout the project implementations should be provided by the qualified registered professionals on behalf of the developer. Any special ground treatments required to achieve the performance criteria must be clearly stated, and the construction specifications and methods are to be clearly spelled out. The developer should provide method statement for the constructions. The method statements provide the details how the constructions are to be carried out. There is a requirement that the pre-construction conditions of the existing structures surrounding the project site to be precisely recorded in the manner of that is indisputable, and if possible, there should be photographic evidence accompanied with written record, and this shall be verified by the design professionals and agreed by the owners of the properties. These pre-construction conditions will serve as the baseline, representing the existing conditions of the structures and the areas surrounding the project site. The relevant information also include the existing ground and water table levels. Let us talk about the performance criteria for the development. It's stated that all work and treatment employed to the infrastructure work. The infrastructure work refers to the roads and drains, must be designed based on the soil investigations, and should be able to sustain maximum settlements of 200 mm for a period of 2 years from the dates of handing over. This is a very important numbers as the requirements for the development on soft soil conditions. They set the limit, the maximum settlements not to exceed 200 mm over 2 years. If you observe this, the settlements is definitely more than 200 mm. Of course, this is due to the total settlements over many years. This is another example here. This is the concrete drain. The foundation is here, and this is the total settlements after 7 to 8 years. You will see that ultimately the drain cannot function to discharge the water. This will become a redundant. In the case of runoff, the water will go elsewhere without following the designated drain, and the entire drainage system is not effective. Now, as far as the guideline is concerned, we are looking at 200 mm over 2 years from the date of handing over. The post-construction settlement shall be determined by observation method. However, during the constructions, the ground settlement shall be monitored and recorded, and these data will be used to predict the post-construction settlement using established methods. All the construction activities affecting the settlement shall be precisely recorded. Having the important performance criteria established, now the solutions, it will be up to the developer. The developer can choose to have the infrastructures such as road and drain to be supported by the suspended system, and in this case, this has totally eliminated the risk of having the settlements more than 200 mm in 2 years, as the suspended systems are typically supported by deep foundations. Now, the problem with the suspended slab system, it will be the cost of the constructions. This will bring direct impact to the selling price of the building units. Now, if the developer wish to have cheaper buildings, they can opt for not having the suspended slab system. This will require proper ground treatments and soil stabilizations, and most likely this will involve deposit to be given to the local authorities upon completions or before the road certificate is issued. The amount of the deposit shall be based on the assumption that the infrastructure works as designed based on the accepted soil investigations and approved engineering drawings subside by 300 mm over a period of 2 years. Now, in case of any portions of the engineering works exceed 200 mm after 2 years from the date of acceptance of the completed engineering works, the developer will have to raise up the engineering works to the design level. It is like the liability of the developer, which the developer should ensure there is no excessive settlement by doing proper ground treatment. Now, if the settlements exceed 200 mm, then the developer will have to rectify at their own cost. Now, if the developer fails to do so within 2 months after being notified by the council, then the deposit which was being paid to the council earlier shall be used to rectify the engineering works to the design level. That means the deposit shall burst, being used by the council to rectify the engineering works. Now, if the developer chooses to use the suspended slab and the pile foundations, there will be very minimum risk of excessive settlement. Therefore, no deposit shall be required. However, there are conditions. The soil treatment methods must not allow inaccessible void to be created underneath the suspended structures, and this shall be determined at the conceptual design stage. That means that when you are using suspended slab system together with the pile foundations, this can prevent the infrastructures from undergoing settlement. However, this cannot prevent the soil from settling. Ultimately, they may be void underneath the suspended slab system. Now, it is important to ensure the voids shall be accessible or open. The guideline did not provide any explanations regarding why it is so. Personally, I believe it is to prevent the accumulations of any natural gas that can be combustible or that may be toxic. There may also be concerns with the void underneath the suspended slab, which could be the habitats of wildlife or breeding place for mosquitoes. These are other issues that can come along with the suspended slab system. However, as far as the structural stability considerations, as well as the functionality issues, suspended slab systems may be used. Now, if the voids are required to be accessed for the inspections and maintenance, for example, that they do not like to run the services over the suspended slab system, some architect may choose to run the services underneath the suspended slab system. This may require the inspections and maintenance of those services. Now, in this case, the headroom for the space should not be less than 2.2 meters, and appropriate drainage and ventilations are to be provided. In terms of the design for the suspended slab, it is stated that the design life load for suspended carriageway should not be less than 16 kN per meter square. This is a typical suspended slab system. What they did here is all the roads and drains are sitting on the suspended slab, and the suspended slab is supported by pile foundations. Over the years, there is no settlements of the suspended slab system, but the ground can still settle. Living rooms underneath the suspended slab system. To ensure the public safety, there should be some barriers to prevent the access of the general public underneath the suspended slab. Depending on the design, sometimes there may be services underneath the suspended slab system. In this case, the areas below the suspended slab should be accessible. and there should be proper ventilations for the workers working underneath the suspended slab.